today I will be running the lab with you. The lab is part of your assignment BE1612. Your assignment made out of two questions. Question number 1, asking you to solve the problem using the method of joints. Question number 2, asking you to solve the problem using the method of sections. At the end, you have to provide a scientific lab report. Your scientific lab report must include at least an introduction section, background theory, methodology, results and discussion, and conclusion. In your introduction, you have to describe both methods that you have used across your assignments, method of joints and sections. Background theory, you have to include all the theories that you worked on or you used again to solve the problems. In your methodology sections, again, you have to describe everything you do from the setup until you get your results. In your results and analysis, of course, you will get some results practically and some of them that you will be working out theoretically, and you have to compare both results at the end and see if they are different, why they are different, by how much they are different, etc. In your assignment brief in here, please follow all of the instructions. The only thing I'm asking you not to follow is that you provide a PDF handwritten calculations. I'm repeating that again. Everything in your assignment report must be typed. Do not use your handwriting for anything that you do inside your report. Remember that everything you do inside your report to be scientifically clear. For example, you have to use free body diagrams, analyze them, explain them, apply your theory to it, analyze that theory and explain them properly. If you need any extra help, then you are welcome to email me or you email your model leader as well. I will start the experiment here today. First, I will show you the experiment setup. We're having here a truss. This truss in here, of course, made out of specific members. These members at each joint, if we take joint B, for example, in here, we will see that joint B made out of 5 members, 1, 2, 3, 4, and 5. Same with the rest of the members in there. Looking at the truss, we will see that it is fixed from one side and it is free from the other side. That means we will have reaction forces acting vertically and horizontally at point A in here, and at the end in here we will have only vertical forces because the horizontal one doesn't exist. The truss is free to move horizontally. We have, of course, here a computer. This computer is using a specific software. It's called Data Studio. I'm just logging in. We are using a Data Studio software to report or record the forces acting internally inside these members. As you can see on here, if I run this in there, the members now, or the truss doesn't have any force applied to it, but at the same time we can still see some readings. Of course, in your reports you have to show margin of errors. Some of these errors they might be human errors or technical errors. Technical errors, you can talk, for example, about the precision of these sensors in there. We have 6 load sensors are positioned on specific locations on this truss. First sensor is here, is recording the vertical forces acting internally on member A in here. We have sensor number 2 representing the force acting diagonally on the member, on the diagonal member in here. Force sensor number 3 showing or representing the force acting on this horizontal member in there. Same, this is force number 4, 5 and 6. These are the 6 sensors positioned on top of these members on this truss. We named the first point in here, which is the fixed point A, followed by B, C, D, E, F, G, H and I. All of these points we will choose, we will pick up specific points that apply the load at. The load here being made out of, we have the hanger. This hanger in here weighs 0.44 kilogram, and each piece of those weighing 0.5 kilogram. So today we will be applying 2 kilogram of these pieces in here, plus the hanger, which is 2.4 kilogram. Those 2.4 kilogram will be applied at specific joints, plus again we will be applying 1 more kilogram at different joints. Today we'll be picking up joint D to apply the 2.4 kilogram, and there you should be observing that once we apply the force downwards, the force amount in here is increased, as you can see on the screen. Same in here, I will be applying 1 more kilogram at point or joint G. Again, you should be observing that the force is increased on the reading in here. I will stop taking the reading. Now, this is our experiment here. We have the truss. The truss is fixed from one side at point A and free to move from point I. We apply the forces downwards at different locations. These forces now acting internally, whether it's upwards, downwards, right or left, positive x-axis or negative x-axis, all of them be recorded by the force sensors as you can see them on the screen. The first top reading in there is representing force sensor number 1, which is this one here on this member. The second reading in there, which is negative 25.94 Newton, representing the second reading from the second sensor. Same thing in here on the third reading, negative 14.84 Newton, representing the reading from the third sensor from this member in here. Same sensor number 4, 5 and 6. Now you take these practical results and you go home and start working out using the method of sections to work out the same reaction forces on the same members exactly. Then you compare your results, the theoretical results, that the calculation you will do with the practical ones, and see that if they both the same or different. If they are different, by how much they are different and why they are different. You have to analyze everything you do. Before you start the method of sections or your calculations, you have to set up your sign conventions. Your sign conventions according to the right hand rules. If you remember them, we take upwards reactions or upwards, the forces that acting upwards to be positive, y vertical upwards to be positive, downwards to be negative, right hand side to the x-axis here to be positive, left hand side on the x-axis to be negative. And again, for your moments, if you take a moment above any point in here, we take the anti-clockwise to be positive, clockwise to be negative, and so on. Once you set up your sign convention, you start finding the reaction forces on these two members at point A and point I. These are the points where you're going to start from. You find the forces acting in there using your equilibrium equations. equilibrium equation starting with the sum of forces on the x direction is equal to 0. You have to sum all of the forces that are acting on the members in here on the x-axis. For example, here at point or joint A, we will have AX in here, and on the other side in here, you will have no x-axis forces acting on them. Now, once you find the force acting on the x directions, if there are any, then try to find the force acting on the vertical direction, whether it's upwards or downwards. Of course, we having AY in here, and also we having here downwards force 2.4 kilogram. Don't forget to convert your kilograms into newtons, multiply the amount of kilograms by 9.81. Same thing in here at point G or joint G. There's 1 kilogram acting downwards, and in here at your point I, you should have upwards reaction force in there. You should be able to calculate them. Using the method of sections after that, once you calculate the reaction forces, you should have either AY or IY. You can use different ways to calculate them if you want. Now, using your method of sections to calculate the forces acting exactly on the same members, same like your sensors. Sectioning means you cut the members in here, or you section the members, or you section the truss, and ignore everything after the sectioning. Don't take anything into consideration. For example, if I cut my truss or I section my truss at point C in here, I will be ignoring everything behind that point. I will be only taking into considerations whatever happening from A to C. And if I'm sectioning the truss at B, I have to ignore everything after B and take into consideration everything from A to B. Same thing in here, if I section it at D or E or F or at any sections on my members in there. Now, once I start to sectioning the truss in here, I will be able to find out the force acting in here. Yes, we found initially the reaction force on AY should be giving you similar results to force number 1. However, this is not the method of sections. We're asking you to find it using the method of sections, where you will have to section the first 4 members in here at B, or you section it diagonally. You will have only the down side or the top side triangles. You can use that to find out your force number 1 using the method of sections. Same with the others. Don't forget to convert and put your units next to your calculation, because numbers without units, they means absolutely nothing. And that's the end of the experiment here today. If you need any help, please feel free to email us.